Hello everyone. Today we will be discussing about the geophysical method that we will use for image the subsurface, near subsurface geology for the region. So till now we have already seen the surfacial topographical mapping of the region using the using the total station and RTK. Today this is the geophysical instrument that is very handy, and we can a single person can easily take it into the field and perform a survey. And so the basic principle behind the instrument that we will be discussing today is ground penetrating radar, that is the short form is GPR. So the basic principle behind this instrument is that the high frequency radio electromagnetic waves are transmitted into the subsurface, and which get reflected from the target due to the difference in the electrical properties of the subsurface, and that is once again detected by the receiver, and that that signal that we get from the subsurface, that is displayed into the radargram. So the basic principle behind the electromagnetic wave propagation deals with the Maxwell equations. So there are total 4 equations that deals with the propagation of electromagnetic waves. So I hope you all must be aware of the Maxwell equations and the Faraday laws. So for the better understanding of the basic principle behind it, you all should read about it properly, and so that you can easily understand about the basic working of the GPR. So today the purpose of the lecture will be that the topics which we will cover in the lecture is how GPR work. Secondly, we will discuss about what we can detect through the GPR, what is the penetration depth of the GPR, and what are the parameters that we should keep in mind during the acquisition of the GPR profiles, and how to acquire 2D and 3D data set in the field, and what are the advantages and disadvantages of the GPR technique. So one by one we will discuss all these things. So the first thing is how GPR works. So as I have also mentioned earlier, that we emit the GPR emits high frequency, that ranges from 10 megahertz to 2600 megahertz into the subsurface, and due to the dielectric properties, that is we call as the dielectric constant or the dielectric permittivity of the subsurface, there should be the contrast between the medium and the target material that we are targeting. The electromagnetic waves will reflect back to the receiver, and these signals we capture it and we analyze it into the radargram. And the dielectric properties, I mean to say, is that the property dielectric permittivity is the property of the material that which defines as how much electrical charge it can hold. If there is completely, like suppose if there is metallic our target material is metallic part, and the medium property like the subsurface soil, so there will be a drastic contrast between the target and the medium. So that can be easily captured through the GPR. The the material that we can easily detect through the GPR are like I said, metallic wires, metallic pipes, plastic pipes, and the geological variation in the subsurface. Although there will be a very minute change, but if there is a drastic change in the geology, that we can easily detect from the GPR. And other things are like if there is some excavation part that has been done, and that the refill part can also be easily detected from the GPR radargram. Apart from that, we can also detect the concrete part or the concrete that can be used in the archaeological surveys, so that we can find out the buried wall structure or concrete structure. So it has a huge application in the archaeological, geological and geotechnical surveys. So basically the resolution of the GPR, if we talk about the resolution, so it is a thumb rule, that at least the target layer that we are trying to detect, it should be at least 1/4 of the wavelength of the incoming wavelength, that the frequency that we are using as a GPR. So the wide range of frequencies that we can use through the GPR, that I mentioned, that we can use from 10 gigahertz, 10 megahertz to 2600 megahertz. So for today's lab, we will be using 350 megahertz GPR. So this we can see that this is 350 megahertz GPR. It is easily, we can move it through the cart. It can be easily used at any area that we can use, that we want to map. And in this you can see that in this unit, this is the shielding, so that the electromagnetic waves that are generated, that cannot go into the atmosphere. And within this shielding or the case, there is transmitter and receiver. So through this, into the subsurface, the electromagnetic waves are propagated and received back to this to this receiver, and the whole result is the signal transferred to the tough pad that we are having, that I will show you in a short time. And once on the right side of this wheel, we are having, there is a odometer fitted in this. So it can clearly indicate how much distance you have covered and how much area you have covered through this. So now I will show you the different components of the GPR. So this is this is the tough pad, so it can be easily latched onto the cart. So I will show you. This is the tough pad. So this is a mini computer kind of thing. So the whole data that we are acquiring, that is getting transferred to this tough pad, and we can easily analyze and interpret through this display or the computer. So to latch it, we can fix it, and through this we can latch easily onto the screen, and it can be easily taken for the survey. So to start with, so this is the case in which our receiver and transmitter is there. So the components, I was discussing about the components of the GPR. So in this you can easily see that this is a GSSI 350 stacking. Hyperstacking, this is the frequency that is given, and hyperstacking is the number of data or the scans that it will be capturing, that is the number of stacking is very high. So the level of noise will be reduced using the hyperstacking feature of this. And this is specialized for the utility scanning. And as this is the slot for the battery, so this kind of battery is attached to this. And this cable that we are seeing, that this goes to the this is for the odometer, and the connection to it is going to this wheel. So the odometer is connected to this wheel, and the connections, if I can tell you, is this is for the communication. So from the data that we will be receiving in this unit, that will be transmitted to the to our tough pad using this port, and this cable will go from this unit to the tough pad. And similarly, this is for the power. So this will connect to the battery, and this will be connected to this port, this power port. So I will attach this. So we have connected the cables, and I am now connecting the battery. And this is for the communication. So using this cable we can communicate with the tough pad. So here we are having a port. So this will be latched to this port for the connection. So I have connected the all the cables and the communication in the GPR unit. So as you can see right now, there is no light blinking in this, and as soon as I power on the screen, the tough pad, as soon as I power on the tough pad, so as you can see that the power light has been is popping out, and as soon as the communication will be connected to between the GPR unit and the tough pad, so blue light will be popped out. So as we can see now, our unit is ready for the survey. So and this is the shielding. This is very important because from the outside of the from the surrounding region, so there will be the input electromagnetic waves which can interfere between the frequency of GPR. So the shielding is very important. So this, now we can latch it out, and it should be noted that the GPR unit, that is the receiver and the transmitter, it should be in constant contact with the ground. So the distance between the receiver, the unit and the ground should be very minimum, so that we can the maximum part of the energy gets into the subsurface, and we can get the high resolution GPR radargram. So as you can see, this is the starting screen of the GPR survey unit. So you can see that this is utility scan for dual frequency and utility scan hyperstacking. So we are having a 350 hyperstacking unit, that is the frequency of the antenna, and this is for the power button, and the symbols this we can see is this is for the battery of the unit, this is showing, and this is the space that is there in this storage storage of the tough pad, and this symbol is for the battery of this tough pad. And if this is blinking, this will be blinking orange, so that means the battery is low. So at least around 4 hours it can easily go if it is fully charged. And to start, we can see that press A1 to start. So as soon as we press this, so we can see that there is a green tick, that means there is a proper communication between the unit and the tough pad. The mode is 2D. So currently the mode is on 2D. We can change the mode through this mode button. As we touch it, it will change to the mode to the 3D. So currently we will show you how we can acquire the 2D data. So the other tab that is showing, that is the playback only. So if we want to see or preview the previous data that is stored in the system, that we can view through the playback only menu. Other is the new project. If we want to create a new project, then we can click on this tab and a new project will be created. And if we want to see the our last project and its setting, we can choose this from this tab, last project tab. So right now we will choose the new project. So here we can see that whole directory has been opened, and we will give a new data path, and this is the keypad and we can give lab practice 2D. So we can see now our GPR has been started, and the name of the lab, the data that will be stored is, the name of the file is lab underscore practice underscore 2D. So this is the typical radargram that we can see. So these are the signals that we right now it is acquiring, and until and unless we will press the start, it will not record it, but right now it is running. So to save the file or the start the survey, you can press on the start tab to start the survey. So I am not starting right now. So this is the oscilloscope that we will see, or the wiggle plot. So this wiggle plot is means like how much energy is getting transmitted to your subsurface. So this, the quality of the signal that is transmitted within the subsurface, that can be accessed through this plot. So this is kind of showing the electromagnetic wave and its positive and negative polarities. So the positive polarity will be plotted as blue color, and the negative polarity will be plotted as a red color. So this is the propagation of the wave that we can see. So it is the overall propagation is combined to one scan that we can that we are able to see on this. So we have to adjust the signal within this portion. So the our signal should not cross this portion, that is the plus 0.25 and minus 0.25 bar that we are seeing. So we have to adjust our for the better interpretation or the better acquisition of the signal. We have to adjust this to between these bars. So if we can so here we are having few options. So we can adjust this wiggle using the signal processes, and other tab which we are having, that is the output options and system options. So one by one we will go through all these. So in signal process we can see scan, gain, filter, line track and maintenance. So to give the input parameters to our system, as I have talked about the target depth, the penetration depth, and the dielectric constant, and the or the dielectric permittivity. So that can be adjusted using the scan tab. So based on the target depth that we want to acquire the data, we can change it. So the maximum depth is through this unit is 10 meter that we can use, but as soon as we will go deeper, that is the 10 meter depth, if we want to, the resolution will get the signal will get attenuated and the resolution will be less. So the purpose of this unit specifically, it can give a high resolution data till 4 to 5 meter. So we will keep it at 4 meter for the this, and dielectric constant also you can you should be aware before getting into the survey. You should be knowing about the overall geology of the region. At least you should know that what kind of lithology I am going to encounter roughly. So based on that we can give the dielectric constant. So as I have mentioned previously that there should be a clear cut dielectric contrast between the target material and our medium. So medium is our soil as of right now. So the dielectric constant of soil is very important parameter for the survey. So as we can see, this is some kind of wet soil that we have having. So the wet soil will be having a dielectric constant of around 9 or 10. You can see. Similarly, you can customize also. So based on that, you can the dielectric constant of some known parameters are given. So if there is a ice or snow, so if we select this snow or ice, so our dielectric constant will change automatically. So you can see it has been changed to 3. Or if there is dry sand, then the dielectric constant is 4. And if we take average soil, dielectric constant is around 14. And if it is wet soil, then dielectric constant is around 25. But as you can see, the top layer is showing the more that the signal is getting out of the our this bar, and beyond that the signal is getting completely attenuated. So this is not a ideal wiggle, so we have to adjust it based on our type of soil that we can encounter. So we can take average soil, uh, or you can customize the dielectric constant, and you can keep it to your own value if you want to give. So if I am giving dielectric constant as 9, then you can see that wiggle is more or less fine, but some data is getting spill out of the bars. So to other things are the scan density. So there are two options, scan density normal and high. So obviously to get a high resolution data, the scan density should be high, and but the thing is the number of space, the quantity of space it will take, it will be more, and the autosave file should be on. The option is on and off, so we should keep it on, always on. So I have shown you the scan parameters. Now we can go to the gain. So gain is particularly, it is enhancing your data. It is with the help of the whole this wiggle is divided into few the based on what your the number of points. So in this we have divided the whole wiggle into 4 parts. So by changing the values of the input signal, we can adjust the wiggle through this option. So if right now gain mode is auto, if I change it to manual, so I can change it. So for the first part, that will be through, suppose this is divided into 4 parts, so the first part will be the GP1, gain point 1. So I can adjust it through this point, and now you can see the wiggle is completely adjusted between this bar by just simply adjusting few values. So the gain point has been adjusted. Filters is you can if you know that there is some noise from the background or something, so you can remove the background removal by giving some values. But it will be okay if we do this during the processing part of the data, because we don't want to lose any kind of the target signal. So if you will give some value to this, it will lose out your data. Similarly, this will be giving you the signal floor. So how much signal it is getting, the real time signal, it can be accessed through this green histogram that is getting developed, the peaks that is getting developed through this. The migration, so if there is a dipping strata that we can encounter within the subsurface. So to migrate the dipping data to the horizontal data, that can be done through the migration. That can also be done through during the processing part of the data. And this is a Hilbert transform. This is a kind of a filter that we can apply to improve our data. And this is that we have seen. Now line track is the special feature that is given to this model, which can detect the live cable within the subsurface. Suppose there is a live electrical cable within the subsurface. So when we will turn on this, and we will use it through the power mode. So there will be two frequencies, that is 50 hertz or 60 hertz. Typically we should keep it on the 50 hertz, so it can easily detect the live cable that is there that is lying within the subsurface. So as of right now we are not having that target, so I am keeping it off. And similarly maintenance, that is there can be a inbuilt GPS, but in this unit we don't have GPS. So this feature will not work. And apart from that, if we go to the output options, so display, how we want to display our result, that can be adjusted through this window. So there are different color tables. As I told you that the positive will be shown in the blue color and the negative polarity will be shown in the red color. So that can be changed through this. We can change it through our required. So now we have changed the color scheme, and by adjusting this we can actually differentiate different kind of target material according to our. But best is this, that we can that and other thing is the color stretch. If you want to stretch the color table through this, that is fine. And the color should be the black on white or white on black, that is different. And we can manage our file. So we can go to the data path where our file has been. We can change the data path where our data is stored, or we can add a new data path through this file. And we can copy or move our data to the USB drive using these steps. And we can also delete the files using the delete file tab. So till now we have seen the basic principle of GPR, how GPR works, and what is the resolution that we can get through the GPR, and the different components of GPR, that is the receiver, transmitter and the control unit. And we have also seen the parameters that we can use while the acquisition of the data. So I will stop here, and we will continue to the next lecture in the next lab. And in that lab we will show you how to acquire 2D and 3D data into the feed. Thank you.